In here there's a pot of flowers and the use of 2 wires, and the wires have T1 and T2 tensions. As you can see, one of the wires, which is the T1 wire, is attached horizontally to a wall, and the other one has an angle of theta degrees to the horizontal, and this entire system is not moving, it is stationary. So we can see that the acceleration in the x direction and in the y direction are 0. So let's look at a chart here. So let's write down our forces and their x and their y directions components. So we have the first force, which is W, which is our weight, no x. Y component is negative because we are looking at positive x and upward as positive y. We have T1, our tension 1 is a force, it's a vector, and the x component is positive because it is pointing in the positive x direction, and in the y direction there is no component because T1 is entirely in the x axis. As for T2, you can see that T2 is in the third quadrant. So for example, like if we draw our axis like this, so this would be our positive x, this would be our positive y. You can see that T2 is in the second quadrant. So our x component is negative, so you can write negative T2 cosine theta, because we are looking at this here is our x component, and here would be our y component, and then y component is positive, it's T2 sine of theta. So if we were to add these up to get our summation of components, then we have T1 minus T2 cosine of theta, and then minus W plus T2 sine of theta. So let's look at x component of F equals ma, which is Newton's second law. So we have T1 minus T2 cosine theta equals m times ax, which is 0 because this entire system is stationary. So this is 0. That gives us T1 equals T2 cosine of theta. Now we have a slight problem here because we do not know the value of T1, T2, so we cannot solve T1 or T2 right here. So next up, we can just leave it right there and look at the y direction. F equals ma in the y direction. So now we are going to look at y component, which is negative W plus T2 sine theta equals m times 0 again, because y component of acceleration is also 0 because this entire system is stationary and there's no acceleration. So that gives us T2 sine theta equals the weight. So we take W from the left hand side of the equation to the right hand side of the equation. So the negative W became positive W here. And we know that W is equal to mass times gravity. So T2 is mg divided by sine of theta. So good news is that we know these values. So 6.2 kilograms times 9.81 meters per second squared, and then sine of 40 degrees. And here we can find T2 which is 94.6 newtons. So we found T2, and then what we can do is substitute value here for T2. So we have T1 equals 94.6 times cosine of 40, and that gives us T1 equals 72.5 newtons. Remember, units of tension is newtons because tensions is a force.